Welcome to Usman Chain Physics Maths class. In my previous video, I have discussed on half-life. I happen to say that half-life can be defined as a time taken for a radioactive sample to decay to half of its original number. And I said there are two people that have found the relationship between N naught, N and T, and that takes us to Soddy and Rutherford. Rutherford and Soddy found that the rate of the decay is proportional to the radioactive nuclei present, and mathematically we can write it like this. So this is the rate of decay is proportional to the number of radioactive nuclei present. That is what this is. So if I remove the proportionality constant here, the equation will turn into something like this. The n over the t equal to negative sign n. So you can see now as I remove the proportionality constant here, the equation has turned into negative lambda over n. The lambda here is constant, but the problem is, where is this negative sign actually coming from? I could still remember. Let me dial back a bit. I said if you have a ball containing n number of radioactive element at time t equal to 0. So after a certain time, this radioactive nuclei in a ball can decrease. It can reduce to half of its original number. That means that the radioactive element is decreasing. That decrease in number brings about the negative sign. So from here we can rearrange it. So from here, we can rearrange it from this point to this point, okay? The n should just come down and the t should come over here. From this very point again, we can just integrate, bring a sign of integration. But I want you to understand this integration has a limit, okay? When a radioactive sample has n number at time t equals 0, then it simply means that the n was n naught. And the time t, at time t equal to 0, we are having t naught. Okay, so after certain time, it has break or it has disintegrate to a certain number, we have n. So this is the limit, and at that time we have t is there. Okay, so from this very particular point we'll have this again, the end over n. Okay, equal to, then we bring out, we factor out the constant outside so that we have this integral t naught, then we have t, then we have the t. Okay, so from that very point we'll start integrating. Okay, when you integrate this, this is just 1 over n. When you integrate 1 over n, you have ln n. Okay, you have ln n. All right, but the limit will come in n naught to n, okay, equals to, then when you integrate dt, you have only t, so we have negative t. Now why am I not writing limit here? Because we know that t naught is equal to 0, so the highest, the only thing, if you substitute, you're going to have your what? T alone. That is why I'm writing it straight, t. Okay, so from here I will substitute the limit of this. So we have ln the upper limit, which is n, minus ln the lower limit, which is n naught, equal lambda t. All right, so from we fall back to logarithm. When you are subtracting, you should divide. When you are subtracting, you should what? Divide. So you factor out the ln into bracket n over n naught. We close the bracket, equality sign, so we have our lambda, negative lambda t. So from here we take the natural log of both sides so that the ln should disappear. So if you take a natural log, you have n over n naught will be equal to e raised to power negative lambda t. As a result of disappearance of this length brings about the natural log. Okay, so from this very particular point, we continue. So we just rearrange here, multiplying both sides by n naught, so that we have n will be equal to n naught e raised to power lambda t. So this is the relationship. If you are asked to look forward the n number of the radioactive sample, you can just use this formula. That is when the constant is given, the time t is given. Are we there? The time t is given, the constant is given, you use the formula and get it. But we are still having problem with the constant. The constant has its own definition. There is a way we can define so that we'll be able to obtain the half-life. This time t is not the half-life. So there is a way in which we can obtain the half-life. So I will encourage you to go to the YouTube and subscribe to Usman Chain Physics Maths class. Ensure that you turn on the notification